Hello, am I audible?
Yes, ma'am. You're audible.
Okay. Thank you so much, sir, for joining. I hope my screen is visible. Okay, so without any further ado, let's start today's session. So, today we'll be discussing week 3 problems and the concepts that were discussed during week 3 lectures. So, first and foremost, what we learned was some basic rules of probability. So, we had learnt about some terms like sample space, null event, sure event in the previous classes. So, we already know that probability of occurrence of an impossible event, which is denoted by phi, is 0. Okay, and also we know that probability of occurrence of a sure event, which is denoted by the sample space itself, that is p omega equal to 1. And if we have to compute the probability of any complementary event, that is probability of a complement, that would be 1 minus of pa. And we also learned about a new term which is called odds of an event. Alright, so odds means that probability that the event is happening by probability that the event doesn't happen. So odds means happen, event E happening by probability that the event E is not happening. So it is a ratio of two probabilities, right? And also we learned if A1 and A2 are two events which are not necessarily disjoint. By disjoint, what we mean, if we say set event A and event B are disjoint, it means that there is no overlap between A and B, or in other words, A intersection B equal to phi, null set. Okay, now when such uh, disjoint events are not guaranteed, at that point probability of A1 union A2 is equal to probability A1 plus probability A2 minus probability of A1 intersection A2. So if we visualize this in terms of a Venn diagram, then let's say this is my set A and this is my set B. So probability A union B, the entire thing would be, we are counting probability A once, probability B once, and we are counting the overlap twice. So that's why we are subtracting this A intersection B part once. Alright, so same thing, we are similar intuition is followed when we are writing in terms of probability. So probability of A1 union A2 is probability A1 plus probability A2. Now if this A1 intersection A2 is uh, a null set, then only we can write that probability of union of AI would be summation of probability of AI, given that uh, uh, AIs are disjoint. All AIs are disjoint. Only then that additive property will hold. Also, we learned the definition of probability the last time, that if all the elements in our sample spaces are equally likely, then probability of any event A is number of points in A by the total number of points in our sample space, that is n. So we learned this, and then we also learned some basic principles of counting. We learned about ordered sets and unordered sets, and also we learned when to use permutation and when to use combination. So when uh, so this is not the all encompassing scenario. We will look into things case in a case by case manner and then we'll solve it. But usually usually the definition is, when we are calculating permutation, we are calculating n factorial by n minus r factorial, and when we are calculating combinations NCR, we would write n factorial by r factorial into n minus r factorial. Now what does this factorial mean? This means n into n minus 1 into n minus 2 into n minus 3, so on, 2 into 1. Okay, so if you are asked to find out 5 factorial, then it would be 5 into 4 into 3 into 2 into 1, that would be 120. Okay, also we learnt about ordered sampling with replacement, or ordered sampling without replacement, that is permutations, or unordered sampling without replacement, that is when we apply combinations. And also we learnt about conditional probability. So given any event B, we know, if we know that event B has already occurred, then probability of A occurring is known as probability of A given B, and this is what we call conditional probability. And this can be computed using this formula, probability of A intersection B by probability of B, provided probability of B is greater than 0. So for conditional probability to be defined, the denominator probability should be greater than 0. Please excuse me. Also, we learned about multiplication theory of probability. That is, we can write probability A into B. This is nothing but probability A and B, or in other words probability A intersection B. That we can write in terms of probability of A given B using this formula, or probability of B given A using this formula. And if we have to generalize it to a multiplication of, or intersection of m events, then we can write probability of A1 A2 AM as probability of A1 into probability of A2 given A1 into probability of A3 given A1 and A2, so on and so forth. Probability of AM given A1 to AM minus 1 has already occurred. Okay. Alright, and then finally we learned about Bayes theorem, which gives us a relation between probability of A given B and probability of B given A. So given that probability A and probability B both are greater than 0, yes, given both are greater than 0, we can write probability of A given B as probability of B given A into probability of A by probability of B. Okay, and if we have to generalize this theorem, then if we consider m events such that all m events are mutually exhaustive, that is, the union of the m events is giving me the sample space, and so A1 and A1 A2 AM, they are the union is adding up to the sample space, and no two event has any overlap. That is, the events are pairwise disjoint. For all I not equal to j, ai intersection aj equal to phi, and if it is given that probability of ai is greater than 0 for all I equal to 1 to m, then given that b is another event which is different from ai, then probability aj given b can be written as probability b given aj into probability aj divided by probability of b, and by by theorem of total probability, that can be written as summation I equal to 1 to m probability b given ai into probability ai. So these individual probability ai's are prior probability, and ai given b is called posterior probability, and b given ai's are called model probabilities. So this is something that we learnt. All right. So let us now solve a few problems which will help us gain more insight into the questions. All right. So this is the question. Let's say I want to purchase a tablet computer, and I can choose either a large or a small screen, a 64 GB, 128 GB or 256 GB storage capacity, and black or white cover. Then how many different options do I have? Any idea how you should solve this? Anything, you can come up with anything. So the first thing is, I have here 3 criterias. Alright. So first criteria is size. There are 2 options, either large or small. Second is storage. Here I have 3 criteria, either 64, 128 and 256. Okay. And then the third criteria is color. Here I have 2 options, black or white. So if I enlist the number of possible things, then I can have a large 64 GB black, large 64 GB white, large 128 black, large 128 white, large 256 black, large 256 white, and similar 6 options with small. So how many options do we have? Here for size we have 2, for storage we have 3, and for color we have 2. So total number of options that we have is 12. Is it okay?
Yes, ma'am.
All right. So then let's move on to the next one. Okay. So here the question says, I need to choose a password for a computer account. The rule is that the password must consist of 2 lowercase letters followed by 1 capital letter followed by 4 digits 0, 1 to 9. For example, this is a valid password. So the question is, find the total number of possible passwords. So the first thing is, what is the total number of digits, or what should be the password length? So they are saying it must consist of 2 lowercase followed by 1 capital letter. So these 2 should be lowercase. This should be uppercase followed by 4 digits, 1 2 3 4. Okay, so for lowercase digits, how many options do we have from A to Z? How many alphabets?
There are three alphabets.
No, A, B, C, D, there are 26 alphabets.
26. Oh, sorry.
Okay, so 26 possible options are possible here in the first place. In the second place, how many options are possible? It should also be a lowercase letter, and there is no restriction imposed that if you put one letter over here in lowercase, you cannot put the same letter. So sampling is with replacement. We can use any number of letters and any number of digits with replacement. There is no restriction as such. So for the second place also, we have 26 options. Is it okay? Do you want me to repeat?
Yes, ma'am.
Okay, where is the problem, or what do you want me to explain once more? So here they are saying that in anyway your password has to be 1 2 3 4 5 6 7. It has to be a 7-digit password, because the rule says that it can, the first two must be in lowercase, that is A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. So how many alphabets? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16
26.
17 18 19 20 21 22 23 26. So 26 options. Okay, you can fill here, you can use any one of these letters to fill the first gap. Similarly, for the second gap also, you have the same 26 options, because here nowhere it is mentioned that you cannot use the same letter twice. So
Okay, so there is no
there
foundation
is no
or
bound or no restriction. So that is why here also in the second place we have 26 options that we can populate the second place with.
okay.
Okay, similarly for the third place, now we can use only uppercase letters. So now we can use A B C D so on and so forth till Z. So here also we have how many options? In uppercase,
26.
here also we have 26 options. Okay, so 26. Right, now they are saying followed by 4 digits. Okay, so now 4 digits here, these 4 should be digits. So for this column, how many options do we have from 0 to 9?
10.
10. So for the second digit also we have 10 options. Similarly for the third digit we have 10 options. For the fourth digit also we have 10 options. So therefore the total number of possible passwords n would be 26 cube into 10 to the power 4. These many opportunities we have. Okay, if we consider the previous example, we had size criteria, we had 2, storage we had 3, color we had 2. So if we could enlist, then total number would be number of options for the size criteria, number of options for storage criteria, and number of options of for color, and we would multiply each of the three different criteria. Similarly, here instead of criteria we have options. So what we are doing, we are multiplying each of these options, and then that would give us the total number of possible passwords. Is it clear?
Ma'am, why we are taking 26 to the power 3?
Because
Like,
here we have 326, 26 into 26 into 26.
okay, okay. So for the lower case, we are taking 2 to the power 26 to the power 3. For the
For
upper case,
for
it is.
for all three together we are taking 26 to the power 3.
Okay, okay, okay. Yes,
See here, we, since the number of alphabets do not differ, the only
ma'am.
difference is in case, that is it is
Mm,
in uh,
lower case or
lowercase or uppercase.
yes, ma'am.
Okay, but then
Yes.
number of options that we can avail is 26 into 3, 2 for the 26 into 26, that is 26 square for the two lowercase positions, and 26 number of options for the uppercase positions. All right.
All right.
Okay,
Okay.
so then the question is, okay, all right. Now the next question is, a hacker has been able to write a program randomly and independently generates 108 passwords according to the above rule. Note that the same password could be generated more than once. Sorry. If one of the randomly chosen passwords match my password, then he can access my account information. What is the probability that he is successful in accessing my account information? Okay, so if we define uh, let's say uh, hmm, hmm, let gi be the event that the ith guess of the hacker matches my password. Okay, so the probability gi happens is that 1 out of the n number of passwords that can be generated. What is my n? 26 cube into 10 to the power 4. So 1 out of n is matching. This is the probability that ith guess of the hacker matches my password. Alright, is this part clear?
Yes, ma'am.
Okay, now Alright, so now probability that the hacker is successful is that probability in any of the ith trials, I mean one of the trials, the hacker's password is matching my password. Alright, so in any of the I equal to union of 1 to 108 passwords, if at least one matches, then the hacker will be successful in accessing my account information, right? So this thing we can write as 1 minus probability of union of GI complement. Okay, then this can be written as probability of intersection GI complement. Alright, now since each of the ith trials are independent, because the hacker is generating independently, we can write this as a product of probability of GI complement. Okay, since the trials are independent. So then we can write this as product of I equal to 1 to 108 probability of GI complement. So this would be probability of GI is 1 out of n matches. So probability of GI complement would be product I equal to 1 to 108 1 minus 1 by n. So the answer would be 1 by 1 minus n to the power 108. Okay, is it clear? So the thing is, the hacker will be successful if in any of it, in at least one of the trials, the password match, the generated password matches my password. So for at least sort of situations we use union. Okay, and then using rules of probability, we can write union of probability of A as probability of 1 minus probability of A complement. That's what we have written. This entire thing, if it is A, then we have written probability A is 1 minus probability A complement. Then by applying rules of probability, union of GI complement is intersection of each of the elements complement. And since the trials are independent, probability A1 intersection A2 can be written as probability A1 into probability A2. So for intersection over all i's, we can write it as product of individual probabilities, and then we have, since this is given, probability of GI complement can be written as 1 minus 1 by n, and here there is no dependence on I, so this would be to the power 108. Sorry. Is it okay? Can I proceed?
How we do the calculation of I is equal to 1?
Okay, so this one, what it
Mm,
means, this thing is
mm.
constant, 1 minus 1 by n. So 1 minus 1 by n, we are
Mm.
multiplying 1 minus 1 by n, we are multiplying 108 times.
Okay, okay.
Alright?
Okay.
Okay, so let's move on to the next one. Okay, so I choose 3 cards from a standard deck of cards. What is the probability that these cards contain at least one ace? So let's define the event A as no ace. Okay, so then probability of at least one ace would be 1 minus probability of no ace. Because at least one, its complement is no. Is this part clear? So if my event is it contains at least, so then the complement is that there exists no ace in the deck of cards that I have. So then the required probability would be 1 minus probability of A, that is no ace. Now I am choosing 3 cards from a standard deck of cards. So how can I choose it? I can choose 3 cards. So a standard deck has 52 cards. Okay, so out of these 52, I am choosing 3 cards. So this is the all possible ways in which I can choose 3 cards. Alright, now
Yes.
now the event is that I choose 3. I want probability A, right? So my probability in question is that I have to choose 3 cards such that none of them are ace. So ace cards are the A type, or the cards with letter A. So how many such cards do we have in the deck? We have 4 ace cards. So out of the 48 non-ace cards, we can choose 3 cards. Then we are sure that there would be no ace in the deck that we have. Okay, so then this probability of choosing no ace would be this thing. Then the required probability, that probability at least one ace, would be 1 minus 48C3 by 52C3. Is it clear?
What is the standard formula for that?
See, standard formula is we are choosing 3 cards from a standard deck. So if the question was that find the probability that 2 are some red and 1 is, let's say, black. Okay, so if the question is like this, we are choosing 3 cards from 52, probability 2 black, 1 red. So then all possible scenarios would be choosing 52, 3 from 52. That can be in
Yes.
any order. Order is unimportant. This is the all possible ways I can choose.
Okay.
Okay. So this
Okay,
is
ma'am.
that definition, that number of events in A by all possible ways I can choose. So this is the thing. Now the numerator is 2 have to be black and 1 have to be red. So there are 26, let's say, black and 26 red. So then we are choosing from 26, we are choosing 2, and then from the other 26 we are choosing 1. Okay, so this is the standard procedure to choose cards from a deck. Now the question was that find the probability that these cards contain at least one ace. So whenever you have something like at least given, it is easier to work with the complement. So the complement of at least one is there is no, because at least one means there could be 1, there could be 2, there could be 3, or there could be 4. Okay, in this case there could be 3. At least one ace means there could be 1 ace, there could be 2 ace, or there could be 3 aces. So the easier way to work around is using complements. At least one ace, the complement event is that there is no ace. Now if your selection should be devoid of any ace, then what you can do, you can just remove the ace cards, and then from the remaining non-ace cards you choose 3 by the total number of favorable events, that was from the entire deck you choose 3 cards. So that this probability will give you the probability there is no ace. Alright, so then the required probability at least one ace would be 1 minus the complement, 1 minus probability of A, or let's say, let us define this as A complement. At least one ace is probability of A. Okay,
It's okay, ma'am.
alright. Let me move on to the next one. Alright. Sorry. So the question is, how many distinct sequences can we make using 3 letter A's and 5 letter B's? Sorry. So the question is, how many distinct sequences can we make using 3-letter A's and 5-letter B's? So in total, how many positions do we have? So we have 3 plus 5, 8
Eight.
positions. Alright, so from these 8 positions, we have to choose 3 positions where we can place A. Or in other words, we have to choose 5 positions where we can place B. So how to do that? This would be 8 choose 3. The order is not important. If we choose this for the first A, this for the second A, this for the third A, that is unimportant. Alright, we have to choose either 3 positions where we have to place our A's and the remaining would be filled up with B's, or the other way around. So essentially it's the same thing as 8 choose 3 or 8 choose 5. Now how to calculate this? This would be 8 factorial by 3 factorial to 8 minus 3 factorial. That would be 8 factorial, 3 factorial into 5 factorial. So we can write it as 8 into 7 into 6 into 5 factorial by 3 factorial into 5 factorial. 5 factorial get cancelled. Then we can write this at 8 into 7 into 6 by 3 into 2 into 1. So this and this gets cancelled. So we have 56. Alright. Or equivalently, we can also use R to make this calculation. I'll just show you what is the command. Can you see the R screen?
Yes.
Okay, so we had to choose n would be whatever was there from which we have to choose. So from out of n positions, 8 positions, we had to choose 3. So that would give us, you see, 56 here. Okay, or equivalently, if we write choose 8 comma 5, that would also give us 56. All right. Okay, so in general, this one nck would be equal to nc n minus k. Okay, this holds for all k greater than equal to 0, less than equal to n. Okay, 4c3 is equal to 4c1. Or 7c5 is equal to 7c2. All right. Okay. Let's move on to the next one. Okay, so the question is 10 people have potluck. 5 people will be selected to bring a main dish. 3 people will bring drinks and 2 people will bring dessert. How many ways can they be divided into these 3 groups? Now, the first thing that you have to note here is that who brings what is not important. That means order as such is not important. The first, nowhere it is written that, I mean, these 10 people are not ordered, that first 5 only have to bring this, or second 5 from person 2 to person 7 have to bring this. Nothing of that sort. So there is no question of order. Alright. So how should we solve this? So total we have 10. So out of these 10 people, let us select 5 person to bring a main dish. Okay. So then how many remains? 5 have already gotten the main dish. So now we have 10 minus 5 person remaining. From that 10 minus 5 person, 3 people must bring drinks. So then for drinks, out of the 10 minus 5, let us choose 3. Okay. And 2 people out of the 10 minus 5 minus 3, we are choosing 2 people to bring desserts. Okay, so it would be drinks and this would be desserts. Okay, so then this becomes 10C5 into 5C3 into 2C2. So if we expand this, this becomes 10 factorial by 5 factorial into 5 factorial into 5 factorial by 3 factorial into 2 factorial into 2 factorial by 2 factorial into 0 factorial. Please note 0 factorial is always equal to 1. Alright, so here this one and this one cancels, this one and this one cancels. So what we have essentially is 10 factorial by 5 factorial into 3 factorial into 2 factorial. Alright. So how will we calculate this using R? We are going to use the factorial command. So let me just show you how to do this. Can you see my R screen? So here I will write factorial 10 divided by factorial 5 into factorial 3 into factorial 2. So that would give me 2520. Alright, so the answer is 2520. Is it okay?
Yes, ma'am.
All right. Okay. Alright. So here the question is, a barcode has 3 red lines, 2 blue lines and 1 black line. So if each ordering of the 6 lines represents a different barcode, how many different barcodes can be generated using this scheme? Alright, so here the red lines, blue lines and black lines, they are, I mean, as a group they are distinguishable, but individually they are not. So how many different barcodes can be generated using this scheme? This would be total number of lines that we have, that is 3 plus 2 plus 1, 6.
6.
So 6 factorial by how many red lines do we have?
3.
3 factorial. How many blue lines do we have? 2
3.
factorial. How many black line? 1
1.
factorial. So this would be how
That's
much? 6
1.
into 5 into 4 into 3 factorial by 2 factorial, 3 factorial. So this would be into 2, 30 into 2, 60. Alright? Okay. Let's move on to the next one. So here they are saying that a company has 9 different branches in which an employee can be placed. If 6 employees are to be placed in the offices, how many different choices are possible? So, for each of the, let's say these are the, why is it not working? Just 1 second. Oh. So 9 different branches in which an employee can be placed. So out of the 9 possible branches, 6 employees or 6 branches have to be chosen so that 6 employee can be fit. So then what will be the number of different choices? It would be 9 choose 6. So that would be 9 factorial by 6 factorial into 3 factorial. So So this would be 9 into 8 into 7 into 6 factorial by 6 factorial into 3 factorial. 6 gets cancelled. Then we have 9 into 8 into 7 by 3 into 2. 3, 4, 12 sevens are 84. Is it okay?
Okay, ma'am.
All right. Here also, suppose a company has 20 employees and a group of 5 employees are to be elected, then how many combinations of for the elected employees exist? So from 20 we have to select 5. So just do this one, choose 20 comma 5. What do you get?
Ma'am, 20 factorial upon 5 factorial into 15 factorial.
By 20, this would be 120. So this would be 6, 3, whatever it is. Just calculate. 19 into 3 into 17 into 16.
$15,504.
Okay. 15504 is the answer. Alright. Okay. The question is, consider an election of 15 employees. A possible bet is to forecast the winner of the election, the second winner of the election, the third winner of the election, and the fourth winner of the election. What is the total number of different combinations for the employees in the first 4 places? Okay, so there are 15 employees. Alright, and 4 would be occupying some positions and 11 would occupy no position. Alright, then total number of combinations would be 15 factorial by 4 factorial into 11 factorial. Now for the 4 people who are occupying these 4 positions, they can arrange among themselves in 4 factorial ways. Alright, these 4 people who are having a position, they can, so the first person can have, it can be 1 2 3 4, it can be 1 2 4 3, it can be 1 4 2 3, and so on. So such permutations there can be 4 factorial. So then this is the total number of ways in which the people can be grouped into winners and non-winners, and the winners can arrange themselves among themselves in 4 factorial ways. So the answer is 15 factorial by 11 factorial. Okay, and we'll see what this comes. Okay, so we'll find out factorial 15 by factorial 11, that would be 32760. Right? So this would be 32760. All right. Okay, let's move on to the next one. So let us consider a bank card with 7-digit personal identification number code. The total number of possible combinations for the PIN is how much? Okay, so here also we have 1 2 3 4 5 6 7, and each of the 7 digits could be filled with 0 to 9, that is 10.
10.
Okay, so then here we have 10 to the power 7. So if do we have 7 zeros here? 1 2 3 4 5 6 7. Yes. All right. Okay. Here they are saying a coin is tossed 2 times. What is the probability of getting at least one tail? So probability of getting at least, so let us first define our sample space. So here we could have head tail, we could have tail head, we could have tail tail, or we could have head head.
Head.
The probability of getting at least one tail is probability of getting HT, TH, TT divided by total number of elements, that is 4.
4.
So that would be 3 by 4. Okay, all events are equally likely, 1 by 4, 1 by 4, 1 by 4, 1 by 4. Alright, so this is nothing but probability HT plus probability TH plus probability TT. 1/4, 1/4, 1/4. So this would be 3/4. Alright, let's move on to the next one. So the question is of the probability that a randomly chosen family in a city takes vegetarian food, non-vegetarian food or both are 0.80, 0.40, 0.30. What is the probability that a family takes either or both? Let A be the event they take vegetarian food. Let B be the event that the family consumes non-vegetarian food. So what they have given is that probability A is how much? 0.8. Okay, probability of B is 0.4 and probability of A intersection B is both is 0.3. Then either or both kind of food means required probability is probability A union B. This is nothing but probability A plus probability B minus probability of A intersection B. So we would have 0.8 plus 0.4 minus 0.3. That would be 0.9. The answer is B. Is it okay?
Yes, ma'am.
All right. Sorry. Let's move on to the next one. Here they are saying the probabilities that an instrument gets damaged due to high voltage or mishandling are 0.3 and 0.4 respectively. The probability that the instrument gets damaged due to high voltage and or mishandling is 0.5. A damaged instrument is randomly picked and inspected. What is the probability that the instrument is damaged due to high voltage as well as mishandling? Here again let's just define A as damaged due to high voltage and event B that the instrument is damaged due to mishandling. So they've given is that probability A is 0.3, probability B is 0.4 and probability and or, this means A union B. this one is 0.5. So we have to find probability A as well as B. So this one, from the previous equation, if you see here, probability of A intersection B, if we bring this part to the left hand side, then we would get probability A plus probability B minus probability of A union B. So the original thing was probability of A union B is probability A plus probability B minus probability of A intersection B. This implies, if we bring it this side, probability of A intersection B is probability A plus probability B minus probability of A union B. We'll just plug in the values then. Then the required probability is 0.3 plus 0.4 minus 0.5, that is 0.2. Okay. Shall we proceed to the next one?
Yes, ma'am.
All right. Thank you, sir. Excuse me. So there are 10 actors acting in a play. 2 actors, one of whom is male, are portraying hero characters. In total, there are 6 female characters. Okay. Let event A describe whether the actor is male, and another event describe whether the character is a hero. What is the probability of a randomly chosen actor being male or hero? Okay, so there are 10 actors, and it is given that 6 are female. In total, 6 female actors. Then 4 should be male. Alright. Then A is an event that the actor is male. So probability of A is 4 by 10 or 0.4. Alright. Next, what they are saying, another event B describes whether the character is hero. So option B is that character is hero. How many heroes do we have? The probability of B is that out of the 10 actors, 2 actors are portraying hero characters. So probability B is 2 by 10. Okay. And probability an actor is male and portraying hero character is given by here. So 2 actors, one of whom is male, are portraying hero characters. So male and hero, we have 1 out of 10. So therefore, the required probability, the randomly chosen actor being male or hero, is probability A union B. Or means union and means intersection. Okay. So this would be probability A plus probability B minus probability of A intersection B. That would be 0.4 plus 0.2 minus 0.1 would be 0.5. that is half. Is it clear? I'm sorry.
Yes.
Okay. Let's move on to the next one. So they have given a day's production of 951 manufactured parts contains 51 parts that do not meet consumer requirements. Two parts are selected at random without replacement from the batch. What is the probability that the second part is defective given that the first part is defective? So A is that first part is defective and B is the event that second part is defective. So we have to find out probability B given A, which is equal to probability of B intersection A by probability of A. Alright, so
Ma'am, please explain this how you formulated this part probability of B intersection A upon probability of
this
A.
is just the formula of conditional probability.
Okay.
Sorry. Okay. So given that, so here we have to look into one thing. Two parts are selected without replacement and probability second part is defective given that first part is defective is that it means that we've already taken the first defective, knowing that we'll take the second defective from that place. So how can we do this? So probability that one part chosen at random is defective is that it should probability of A is one out of so sorry, so this is I am choosing one second. His production of 9 contains 51 parts that do not meet customer requirements. So these 51 are actually my defective pieces. Alright. So yes, so instead of doing it this way, Instead of formulating it this way, let's say I'll write it here. So choosing the first part as defective, so two parts are selected, probability second part is defective given that first part is defective. Probability, let us say I'm writing it as A given B, probability A intersection B by probability B. So probability B that a randomly chosen part is defective is that it could be either of the 51 divided by 951 products. Okay.
But the question is saying that two parts are selected randomly without replacement from the batch. So
yes, so okay, so I'll make it easier. Instead of formally putting it, so let's say the first part was chosen, then the first defective can be chosen in 51 out of 951 ways. Okay, now given that this has already occurred, then we have the first part is already defective. Now since the first one was already defective, it was already chosen, then with the second part can, so out of these 51, one has already been chosen. Okay,
yes, ma'am.
so that's for the second one we have 50 options left out of the total of 950.
Okay, got it. This is the process of selective without replacement.
Yes, without replacement.
Yeah, okay.
So since first part is already selected,
Okay, got it.
out of these 51, one is already removed. So given that information, now out of these 950, I can choose, I have 50 defectives to
Left.
choose from. So then
Yes.
this would be 1 by 19. Alright?
Okay. Okay, ma'am. Got it.
Alright. Sorry. The probability that a diagnostic test correctly diagnoses a disease is 0.3. If the test is done on a person having disease, then the probability that the test is positive is 0.6. What is the probability that the person on which the test is positive has the disease? Let's say E be the event that test is positive and D be the event that person has the disease. So we have been given probability E given D is equal to 0.3. No. We just have to formulate this properly. So if a test is done on a person having the disease, probability of testing positive is 0.6. Yes, so probability of testing positive given disease is 0.6. And probability of disease is given as 0.3. Then the required probability that the person on which the test is positive has the disease, that is probability D given E, given that the test is positive, this is given by probability E given D into probability D by probability E. No, sorry, my bad. So here what they have is that the probability that a diagnostic test correctly diagnoses a disease is 0.3. If a test is done on a person having the disease, so given disease, probability of testing positive is 0.6. What is the probability that the person on which the test is positive has the disease? So we are asked to find out probability that the person has the disease and tests positive, that is probability E intersection D. So this would be probability E given D into probability D, that is 0.6 into 0.3 is 0.18. Is it okay? We'll move on to the next one. So an insurance company believes that people can be divided into two classes. Those are accident prone and those that are not. Their statistics show that an accident prone person will have an accident at some point within a fixed 1 year period with probability 0.4, whereas this probability decreases to 0.2 for non-accident prone person. If we assume that 30% is accident prone, what is the probability that a new policy holder will have an accident within a year of purchasing a policy? So probability of accident can be written as probability accident intersection accident prone plus probability accident intersection non-accident prone. This we can write as probability of accident given somebody is accident prone into probability of being accident prone plus probability of accident given non-accident prone into probability of non-accident prone. This is nothing but the theorem of total probability. Okay. So then this is given. Accident happens given somebody is accident prone is 0.4 and probability of accident given somebody is non-accident prone is 0.2. And 30% of the population is accident prone, that is probability accident prone is 0.3 and non-accident prone is 0.7. So this would be 0.12 plus 0.14, that is 0.26. This is the answer. Is it okay?
Yes, ma'am.
All right. All right. So a manufacturer of car parts knows from past experience that the probability is 0.8 that an order will be ready for shipment on time. The probability is 0.72 that an order will be ready for shipment on time and will also be delivered on time. What is the probability that such an order will be delivered on time given that it was ready for shipment on time? So let A be the event that order is ready for shipment on time. So probability A is 0.8. Probability, let's say B is that order is delivered on time. So here they have given A intersection B is 0.72. So now the question is, what is the probability that an order will be delivered on time, that is probability B, given it was ready for shipment on time? So this would be probability of B intersection A by probability of A, that is probability of A intersection B by probability of A, 0.72 by 0.8. So this would be 0.9. All right.
Yes.
Okay. Thank you, ma'am. Here they are saying an office has 20 persons in a group and 5 of them are not fit to work a particular job. If 3 of the persons were selected at random and removed from the group in succession without replacement, then what is the probability that all the 3 persons are not fit to work? An office has 20 persons in a group, 5 of them are not fit to work for that particular job. 3 persons are selected at random and removed from the group in succession without replacement. What is the probability that all the 3 persons are not fit to work? So the required probability is that probability first person not fit into probability second person not fit into probability third person not fit. Okay, so first person not fit means we are selecting 5 from the 20. Okay, so once we have removed out of the 20 possible people, 5 people are not fit to work, we could choose anyone. Okay, so this is essentially 5C1 by 20C1. Alright, into, so if we have already removed the first one, then we have 4 remaining options and 19 people to remove it from. Okay, and then we have 3 people not fit out of the remaining 80. So how much does this come to be? So this 5, 4, 20 cancels. 3, 6. We have 1 by 19 into 6. So we have 4, 5. 1, 1, 4. B is the answer. Is it okay?
Yes.
Alright. So that was all I had for today. Do you have any questions? Anything you want to ask about today's session, or any doubt in general so far?
And can you brief a little bit about the sampling part, the second question, or maybe the earlier?
Second question, which one?
Uh,
Just give me an example.
Now we were discussing about some sampling parts, like how to take samples.
Okay, so sampling, as I understand, there could be 2 schemes. One should be with replacement and other
Yes, ma'am.
is without replacement. Okay, So let's say I have a pouch and I have 10 distinguishable toffees. Okay, of different companies. Let's say one could be Candyman, one could be Eclairs, and something something. So from here, if I am selecting, let's say I select 5 toffees at random. So what I'm doing, I'm going and picking one by one toffee at a time. By default, what do you think? If I say you just take 5 toffees from this pouch, so by default what we mean is we are sampling without replacement. That is, we once we are taking one toffee out, we are not replacing that toffee into the pouch again. So let's say in my first trial, first attempt, I am taking 1 out of 10. In the second attempt, I have already taken out 1, so I am taking 1 out of 9. In the third attempt, I am taking 1 out of 8.
8.
Okay, so this scheme is without replacement. Now, but then if let's say my sampling scheme is such that I have numbered balls over here, okay, 1 2 3 whatever. My sample scheme is that I am taking it out one ball at a time. I am noting the number in my notebook and then I am putting it back to the same pouch. Okay, and I'm carrying out this experiment 5 times. I'm taking one ball out, I'm noting the number, and I'm then putting it again. So this scheme is called with replacement. Okay, so here what happens in my first trial, I am selecting 1 out of 10. In my second trial, I am again selecting 1 out of 10. Okay, is this clear to you?
Yes, ma'am. Okay.
Okay, so whenever we have something with replacement, what we mean to say is that I am putting, I'm collecting samples, I'm putting it back, and then I'm again collecting. So what happens here, like in this question that we had of, let's say this one, 2 parts. Okay, here they are saying 2 parts are selected randomly without replacement. So what it means is that, so first, given that first part is defective, it means that we have already taken out one defective part. So here my denominator for the second trial is changing. You see, initially I had 951. Now since one has already been taken out, I have, and that one was defective, now I have 950 total units, out of which 450 could be, any of these 50 I could take out, that could be a defective piece. So this is without replacement. If it was given that 2 parts are selected with replacement from the batch, then the, given that whatever happens in the first, even if the first part is defective, we are replacing the place. So then the answer would have been 51 by 951 itself. Do you get my point?
Yes, ma'am.
All right.
Ma'am, one question from my side also. Please explain question 12. Because at last you uh, formulated the intersection part, that what is the probability that a person on which the test is positive has a disease.
Hmm.
So why we are choosing the intersection part here? Because earlier you have some formulated that probability of diagnosed upon the probability of a positive test, I think.
Yes, yes. No, see here,
Mm,
initially I made a mistake because
mm,
the question says that what is the probability that the person on which the test is positive has the disease. It means that both the events have occurred together,
okay.
that the test is also positive and the person also has the disease. So
Okay.
whenever we have such both criterias imposed together, that
Mm,
is the case when we use and or intersection.
intersection. Okay.
What given means is that, like here it is shown that if the test is done on a person having the disease,
Mm,
probability test is positive is 0.6, which means given that you already have the disease, the
mm,
probability of you testing positive is 0.6. So given criteria are different. Given criteria means something that has already happened. With that knowledge, I am proceeding to something else. But
okay.
and conditions are different. And condition means that both events are occurring simultaneously.
Okay.
Okay, so this was the
Okay.
mistake that I made.
Okay. Got it, ma'am. Thank you.
All right.
Thank you,
Any
ma'am.
anything else? Please feel free. Okay. If not anything, then I will close this session today and we'll see you next week. Thank you so much
Okay.
for joining. Thank you.
Thank you for
Thank
the
you, ma'am.
class.
Thank
Okay.
you.